Scientists are racing to grow human teeth in the lab. A strange section of teeth organoid grown in the lab in King's College London. It's not surprising that many people fear the dentist. Replacing a teeth often requires invasive surgery and implanting a titanium screw into a patient's jawbone, then waiting months for that to strengthen into an artificial root before attaching a crown or cap on top of it. But research groups around the world are working to find ways to implant or grow rare biological teeth in the human jaw. That may be a way off, but at King's College London, Anna Angelova Belfoni, director of the postgraduate program in regenerative dentistry, has been experimenting with lab-grown teeth for almost 2 decades and was part of the teeth team that in 2013 grew in a teeth from human and mouse cells. This year, she led a study that built upon that work and achieved a breaking through in the material used to house the growing tooth in the lab, which better mimics the actual environment where biological teeth grow in the mouse. It's a key step on the way to replacing the mouse cells with human cells and stimulating them to form a tooth. The idea of creating a lab-grown teeth dates back to the 1980s. Forfoni said, but the one that she and her colleagues created over the decades ago was the first that used adult human gingival cells, which make up the gums and are obtained by lightly scratching the inside of the mouth and combined them with the progenitor tooth cells taken from the mouse embryo. It's almost like the tripod, she said about the elements that contribute to growing a tooth in the lab setting. The two types of the cells engaging in tooth making in the sort of the conversation, and then we have the environment where this happens. The environment, which researchers call the scaffold, is essential to the formation of the lab-grown tooth, and it's a subject of the Forfoni's most recent study. In 2013, Forfoni said used the scaffold made of the protein called collagen, but now use the hydrogel, the type of the polymer with a high water content, explained Chu Chen Zhang, a doctoral student at King's College London and the co-author of the study. We gathered the cells from the mouse embryos and then mix them together and spin them down to get the human small cell pellet, he said. Then we inject this pellet inside the hydrogel and grow it for around 8 days. Because the work focused on the environment, human cells aren't needed. At the end of the 8 days, tooth-like structures will have formed inside the hydrogel, which was developed in the collaboration with the Imperial College London. In the 2013 research, these tooth primordia were transferred into the mouse, where they developed into the tooth structure complete with the developing root and enamel. Many challenges remain before the lab-grown tooth can be used in the human patient, but the new material helps with some piece of that puzzle. Perfoni said by improving the conversation between the cells that are tasked with making a tooth. Researchers still don't know exactly how to replace the embryonic mouse cells with adult human cells, but if that puzzle is solved, Perfoni ambitions two possible ways to integrate uh, lab-grown teeth into everyday dentistry. We either grow a tooth up to the certain stage of development and then embed it into the tooth socket, where a lost tooth was and where the new one will have the potential to fully grow into a biological tooth, incorporating itself within the organic structures such as the bone and the ligament, or we fully grow the tooth first and then implant it in surgically. It's still too early to say which approach will be more viable. The advantages of the rear tooth. A rear biological replacement tooth grown from the patient own cells would offer many advantages over the crown or implant. First, it would be accepted into the tissue without inflammation or rejection, but it would also feel exactly like a rear tooth, unlike implant that lack feeling and elasticity as they are simply fused into the bone. According to the Victor C. M. Neves, a senior clinical lecturer at the School of the Clinical Dentistry of the University of Sheffield in England, Forfoni has long been a pioneer in the field of whole tooth regeneration, serving as the inspiration to many researchers around the world. Her new research tackles a key factor in the production and potential industrialization of this technology, the use of matrices in whole tooth regeneration, said Neves, who was not involved with Forfoni's study. The findings, he added, highlights the importance of creating an environment that can support whole tooth engineering for clinical application. The more researchers who contribute to advancing this field, the sooner humanity will be able to reap these benefits. Other researchers work in the same field are using a variety of different techniques to grow teeth. Takahashi and his colleagues at the Medical Research Institute Kitano Hospital in Osaka are developing an antibody-based treatment aimed at promoting the growth of teeth in people with conditions such as anodontia or the congenital lack of teeth. The treatment has entered the human clinical trials and could be ready by the end of the decade. In late 2024, the team led by Pamela Yelik at the School of Dental Medicine of Tufts University grow human-like teeth created from the human and pig cells in pig. Pig, like humans, regrow their teeth several times over the course of their lives. The ultimate aim is to prompt the cells in the human jaw to grow new teeth without using any pig cells. At the University of Washington, a team led by Haneli Luhola Baker, a professor of biochemistry and the associate director of the university's Institute for Stem Cell and Regenerative Medicine, has successfully grown dental stem cells from human stem cells mined from donated wisdom teeth. We aimed to uncover the molecular blueprint of human teeth formation and to recreate that process in the laboratory, she said. While Forfoni's study builds tooth-like structures from existing dental tissues, our platform generates the key human tooth-forming cell types from scratch and guides them along authentic developmental trajectories. As for when the fruit of all this research will become available, Hola Baker believes that we won't have to wait that long. Although clinical translation will take time, momentum in this field is accelerating, heralding a future in which biological tooth repair or replacement becomes the realistic option within the coming decades, she said.